Hi, I'm Ishtha and I will be introducing you to the AI design sprint and breaking down day one of the sprint for you. First off, the AI design sprint is a time boxed working sprint and it's meant to turn an AI opportunity into a clear, build ready product direction. The sprint surfaces questions like what problem should my AI solve? What should it not touch? When does AI act and when should the human stay in control? And what does good look like for accuracy, trust, usability? To uncover answers to these questions, we use the sense, shape, steer framework, which we'll get into in just a bit. The participants for this sprint can be divided into two groups. The core team, which should be present for the entirety of the sprint, includes a UX researcher, UX designer, product manager, and AI or ML engineers. Additional participants from business, backend engineering, SMEs, and compliance or security can attend as per need. The AI design sprint is designed to run for 5 days, with each session lasting between 90 to 120 minutes a day. However, the format is flexible and can be made more lean to run in 3 days or expanded to 7 days, depending on the complexity of the AI opportunity and the resources at hand. Before we dive into day one and the sense phase, there is some important prep work that each team member should complete independently. What you bring into day one directly shapes how productive the sense phase will be. Before day one, each team member should spend around 60 minutes answering the following questions. Note down your answers individually and you can use them to share your thoughts on day one. This prep is broken down into 2 steps. In step 1, you can start by grounding yourself in the problem before thinking about AI at all. Ask yourself these 2 questions. What specific user task or workflow is broken or taking too long? And where in that workflow does AI have the most realistic chance of making a difference? These 2 questions help you arrive on day 1 with a point of view rather than starting from scratch in the room. The goal is not to have the final answers, it is to have thought it through enough to contribute meaningfully to the group discussion. In step 2, the questions are tailored to your particular role on the team. Each person brings a different lens to the problem, and that is exactly what makes sense phase so rich. Here is what each role should prepare. Everyone on the team should review any existing research that exists in the problem space, which could include interviews, analytics, support tickets, etc. And you can note down the top 3 user pain points you believe are part of the scope for the sprint. The UX researcher and designer should identify a couple of existing user journeys or workflows where they feel friction is highest. Feel free to bring screenshots, flow diagrams, or even rough sketches to the session when you enter on day 1. Product managers can focus on documenting the business metrics which are most affected by these problems. You can come prepared with specifics, numbers, trends, targets, because vague problems are hard to solve with AI. Engineers or developers can note down what data is already available in your current system, structured or even unstructured ones, any existing API integrations, and which AI capabilities are already in the stack, if any. All these answers ground the rest of the team in what is actually feasible. With that preparation done, you are ready for day 1. Let us now move into the sense phase. In this stage, we uncover where the artificial intelligence adds real value and where human judgment must lead. This particular stage blends research, data mapping, and behavioral insights, and it defines what the AI should understand and why it matters. To do this, we have divided sense into 5 parts. Part 1 focuses on the problem space. It ignores the AI completely to start with and focuses on the user, and it helps us understand who they are, what are their key pain points, and how are they solving it now. Each of the sprint participant writes down their thoughts on a sticky note under the questions. Here is where the reflection done on the day before will really help. Part 2 is the AI opportunity. Here we explore, in the light of the pain points we listed in the previous part, where could AI bring in relief? Among all the pain points that were discussed, where is it that AI can come in and elevate that experience? Again, participants put down their thoughts on stickies and then we discuss. Now, in order for AI to undertake the tasks mentioned in question 4, what data would AI need and what is available currently? This question is aimed at grounding the AI opportunity in current data boundaries and to narrow its scope for the near future. Part 3 is focusing on defining the AI role. Here we align on the mode of the AI. A co-pilot, an agent, a conversational AI, or ambient, based on the problems the AI is meant to solve. We also try in as much detail as possible to outline where in the user journey will the AI come in to assist. Where, based on user action, will it take an autonomous decision? The mode you choose in part 3 has direct and practical implications for model selection. Each mode demands a different profile of model. A co-pilot that assists but defers to human can often be a lighter, faster model. It does not need to plan ahead or take sequences of actions. An agent that acts autonomously needs a model with strong reasoning, reliable tool calling, and the ability to handle multiple steps. This is where capability matters most and where model choice has the highest stakes. You do not need to name the model yet, but choosing the mode here is effectively choosing the profile of model that the team will be evaluating in shape. Part 4 outlines the risks and guardrails for the AI. This is where the team thinks as one about the risks of AI being wrong, the kind of oversight that the AI will require, and where the action boundaries of the AI lie. Part 5 is meant to outline the success criteria for our AI opportunity. It is important we think about what would signal success for the user, what would indicate high trust towards AI. These metrics will evolve as we move on to the next phase of the sprint, but it is important to reflect on these early on. This brings us to the end of day 1. Congratulations! By the end of day 1, you should have a clear AI opportunity statement that will serve you for the rest of the sprint and specially help you kick off day 2. But before we hand over to the shape phase, I want to walk you through one more important piece. The post-sense reflection. Much like the pre-sprint reflection, this is an individual and offline activity to be completed before day 2. Spend 20 to 30 minutes alone working through the given questions. Answer for each use case identified on day 1 and bring your answers to the start of day 2. This will directly inform how you kick off shape. The questions are: what does a good enough AI interaction look like for the use case? Describe it in plain language and don't think about technology yet. Just describe the experience as the user would feel it. What would they do? What would the AI do in response? And what would signal to them that it worked? Also think about what data does the AI need to do this, and do we have it? While this is addressed to some extent in day 1, go back, take some time to think about this a bit more deeper because this question is critical. If the data is not available, what is the workaround for this prototype? The answer will directly shape what is feasible to be built on day 2. Because if the data does not exist yet, the prototype will need a workaround such as synthetic data, curated sample, or manual input step. And the last question asks, should a designer prototype this or does this need an engineer? This is not about hierarchy. It is about the right tool for the job. If the prototype needs to call in a live model API or handle real data, an engineer should lead. If it can be built with a no-code AI tool or a design-to-code platform, A designer can do it. Either path is valid, but the team needs to know before shape begins. Bring all these answers to day 2. They will directly impact the opening of the shape phase and help the team move into prototyping with clarity rather than ambiguity. I will now hand it over to him to take you through the second phase, shape.
Hello, I'm him. Thank you, Ishra, for walking us through the sense phase. I'll now take you through the shape phase of our AI sprint. Before we start, let's understand what shape does. Very simply, if sense is about understanding the problem and gathering insights, shape is where we turn these insights into AI experiences. The shape phase can be divided into 2 days. Day 1 focuses on defining the AI behavior, which we'll get into right now. And day 2 focuses on translating that behavior into design. So let's get started. We start day 1 by grounding ourselves in the core problem identified during sense. We do this by mapping three things: the different user types impacted, their key pain points, and how they work around the problem today. We have created this framework that helps capture these points. You can add or remove cards based on a requirement and context. Current workarounds are especially important because they tell us where users are already compensating for system gaps and where AI needs to be careful, supportive, or optional. At this point, it's crucial to prioritize which pain points to pick for AI solutioning. One practical way of doing this is by looking for problems, moments, or pain points that are repetitive, data heavy, or are prone to delay. We have this framework that should help you prioritize the problems that you should pick. Once you have identified the crucial pain points, we treat each one of these pain points as its own design problem. We take these pain points to a structured set of questions. These questions will help us understand five things: user clarity, AI context completeness, urgency, disruption risk, and risk radius. We map them to the appropriate AI pattern and behavior. This step helps us avoid using AI where it does not belong and over automating things that should stay under user control. Once we're done with this exercise, we would have built enough context into the pain points. We now then move into the next step, the AI pattern selector worksheet. In this exercise, based on the information gathered in the previous exercise, we map the AI pain points to the appropriate AI modes and AI patterns. Here we have given various interaction modes and AI patterns to help make this decision. At the end of this exercise, we would have a list of different AI patterns to be used in our solution. Before the day ends, it's crucial to understand if these AI patterns will work together, and if there is a conflict, how exactly do we plan to resolve it. This marks the end of day 1. We have clearly defined who the AI is helping, what problems it is addressing, and how involved it should be. We now move into day 2. We start day 2 with AI touchpoint mapping. This is an exercise where we try to understand the complex interaction between the system, AI, and humans. Here we map four things: what action the user will take throughout the journey, the actions the different AI types will take in the journey, the complex decision points, and the error scenarios and recovery scenarios in the journey. What we are trying to do is gather enough information to help us facilitate the AI prototyping exercise. Here we are trying to understand moments that are high risk, meaning they should be less on AI autonomy and have high human control. Medium risk, which means AI suggests and human approves. And low risk, probably moments that can be fully automated. We're also looking for data gaps, and we're also looking at how the system will gather feedback from the users. Once we're done with AI touchpoint mapping, we'd have enough information to move to our next step, which is AI prototyping. This is an exercise that can be picked up by the design team or the engineering team. But the idea is to quickly create a prototype that mimics AI reasoning, tone, confidence, and workflow without putting a lot of engineering effort. We would quickly create the prototype and validate it with stakeholders and users and iterate as much as possible. At the end of this exercise, we want to answer three things. What are the low confidence areas in the AI workflow? When and where is a user intervention required? And where are the data gaps and how do we address them? The next step is to create storyboard. The idea is that after AI prototyping, we'd have enough information about our users and how they're feeling about the solution to create storyboards. The idea here is to capture user reactions throughout the workflow and not just at a single moment. So each frame captures the user action, the user goal, the context he or she is in, and the design decisions. At the end of this exercise, would have enough information to help us create wireframes. But before we start wireframing, we need to make sure that we have information about all of these 8 points: user goals, AI capability, inputs needed, output format, interaction flow, state and memory, user control, trust and limits. At this point, we would have enough clarity to move into low fidelity or mid fidelity wireframes for early validation. When creating wireframes, one important thing to note is to test ideas quickly. Instead of focusing on details, focus on high level solutions so they can be validated either with stakeholders or real users. This brings us to the end of the shape phase. We've moved from insights to AI behavior to concrete interactions. From here, I will hand it over to Pavan, who will walk you through the steer phase.
Thanks, Em. That was a great walkthrough of Shape. Hi everyone, my name is Pawan, and now I'll take it from here and walk us through Steer, which is day 4 of the AI design sprint, the stage where we define how the AI experience will be evaluated, governed, and improved once it's in use. After Sense help us define the right AI opportunity and Shape helps us design the experience, Steer asks the hard question: how will we know this AI is actually working the way we intended? Because AI doesn't just ship features, it produces behavior, and behavior needs standards. In this stage, we bring structure to ambiguity. We define accuracy thresholds, risk boundaries, usability expectations, trust indicators, and learning loops. So AI behavior remains intentional, explainable, and accountable. The goal is simple: establish shared success metrics, guardrails, and feedback signals for the AI experience. In the workbook, Steer is not a checklist. It's a set of structured questions that are paired with metrics designed to force clarity before you build. Now, we guide the teams to think in terms of usefulness and trust and not just technical correctness. Before we jump into metrics, we guide the teams with clear directions. We ask them to first review the AI concept defined during sense and shape. Steer assumes the AI experience is clear, and the stage is about defining how its behavior will be judged in real world usage. We ask to emphasize on outcomes, not on implementation, and to think in terms of usefulness and trust and not really just binary correctness. Use examples to guide thinking, but capture measurable criteria. We also accept that there will be some uncertainty that will remain, and we will document it intentionally. And most importantly, the questions in the workbook are not really rigid, they're meant to be adapted. For instance, if you're building a healthcare assistant, a workflow automation feature, or a financial copilot, or a generative content tool, the structure remains the same, but the thresholds, risks, and metrics will vary by domain. Now, from here, we'll move on to the structured metric categories. The first category that we'll look at is accuracy metrics. Here we start by asking questions like, how often is AI correct? Where does it perform well or poorly? What kinds of mistakes happen the most? Because accuracy is not really just about averages. We look at edge cases, complex inputs, and patterns of failure. Because if the AI is frequently wrong, the trust, adoption, and safety will never stabilize. We don't guess. We review real examples, compare outputs to expert judgment, track error patterns, and retest scenarios after changes. The next section that we look at is fairness metric, where the idea is to evaluate, does this AI work for everyone? Average performance can hide serious issues. We ask, does performance vary by user type, language, region, or input type? Are some differences acceptable and which ones are not? This is not really about solving fairness globally, it's about making sure the quality does not quietly degrade for a specific set of users. The next category that we look at is usability metric, which is really about, can people actually use it? Even the most accurate AI fails if users cannot understand or use it. Therefore, the kind of metrics that we evaluate here are task completion rate, that can users accomplish their goal. For example, users complete tasks 20% faster with AI but frequently misinterpret confidence levels. What is the time to decision? How long does it take to use AI assistance? What is the error rate, or does it interrupt normal process, which is the workflow disruption? Because AI should support the workflow and not complicate it. The next metric that we'll look at are the trust metrics. Are users actually able to believe it? Because trust is everything. If the users do not have trust in the solution or the AI features that we are providing them, they will never be able to use it. So here we measure things like adoption rate. What are the actual percentage of users from the set of eligible users who are actually using it? How often do users accept the AI suggestions? How often are users actually overriding the AI suggestions, which is also known as the rejection rate? Are users willing to recommend this to others? Or the confidence statements, that on a 1 to 5 scale, I have immense confidence in this AI product. Because if users override AI constantly, it means something is broken, even if accuracy metrics look fine. The next metric that we'll look at are the safety and risk, where the idea is actually to say that, is the AI staying within the guardrails? High impact failures are rare, but they're always costly. Therefore, the things we define here are, what are those high risk errors, where what failures would be unacceptable or dangerous? Or things like hallucination rate, how does often the AI produce incorrect or made up information? Things like confidence misalignment, where the AI is acting confidently where it should not. Does low confidence appear clearly or not? Things like autonomy limits. Does the AI ever act without the required level of human oversight? Or things like escalation behavior, that does the AI hand off to a human when risk is uncertain or high? This is where we explicitly define what must never happen. The next category that we look at are the feedback loops. That, is the AI learning from its users in the right ways? Here, we're trying to clarify what counts as a feedback, what should not be learned automatically, when is an expert review required, how often should the AI be evaluated or retrained, or if the user feedback that we are feeding is clear enough and reliable enough for the AI to learn. Without intentional feedback loops, AI either stagnates or degrades. The last metric that we'll look at is the operational matrix, that, can the AI perform reliably in real world conditions? Because performance and reliability matter. Things that we assess here are things like latency. Is the AI fast enough for users to use in workflow? For instance, the response time averages to 2.1 seconds. What's the failure rate? How does often system timeout or crash or just fails to respond? What is cost per use? Is the interface cost sustainable as adoption grows? Or does the performance drop during high volume usage? An AI system that's accurate but too slow or too expensive will not survive in the real world usage. As we go through these matrix, it's important to clarify something. The purpose here is not to produce hyper precise numbers. We are not expected to walk out of a design sprint and declare that our accuracy must be 73.3% or that the latency must be exactly 1.8 seconds. The level of precision will come later through measurement, testing, and real world usage. What we're doing in Steer is defining directional thresholds and boundaries. For example, is 60% accuracy acceptable? Probably not. Is 95% required? Maybe, if the task is high risk. Is under 5% high risk error rate non negotiable? Possibly. We're not picking decimal points. We're defining what good enough means for this context. Because without that conversation, teams either over engineer or ship without clarity. So the values may evolve, they will mature, they will get refined during the build and pilot. But the thinking, the expectations must be explicit before we start. And once we've defined those expectations, even at a directional level, we can summarize success clearly. We will know this AI experience is working when our defined quality bar is achieved, our risk boundaries are respected, and real world usage provides clear signals for improvement. This statement becomes our North Star for build and iteration. After day 4 of steer, we move on to day 5, which is conclude. Day 5 is where we stop designing and start committing. Over the past 4 days, we've defined the AI opportunity in sense, defined the experience in shape, and established guardrails and success criteria in steer. Today is about bringing all of that together into a build ready blueprint your engineering team can actually act on. The goal of Conclude is simple: finalize a prioritized, feasible, and clearly owned plan to move the AI experience into build. Now, what actually happens on day 5? What we've done is that we've broken it down into 4 parts. Where the first part is that we start prioritizing what will be built. So we make deliberate decisions on what will be phase one or the true MVP, what will move on to phase two, and what are some of the things that will be deferred. Because not everything built at once. If it is not prioritized, it becomes accidental scope. The second thing that we do here is to validate the build feasibility. We pressure test some of the things like technical readiness, data availability, model constraints, instrumentation for matrix, and then the timeline realism. Because if something is not feasible, we'll need to adjust it now and not halfway through implementation. The third part is to assign end to end ownership. So, what we clearly define here is who leads implementation, who owns the AI feature as a product capability, who monitors quality and risk, who handles deployment and incidents, and who decides when updates or retraining would happen. And the last part is where we document any open risks and then the validation plan of things that we need to validate during the build period. Because uncertainty does not disappear, it gets managed. Things that we capture here are what are some of those high risk scenarios, be it failure or success? What are some of these assumptions that we need to validate during the build period? What are some of those early warning signals that we will monitor right after launch? After day 5, what you walk away with is not just ideas. What you have is a defined AI experience scope, validated AI concepts and user flows, success and quality criteria is well defined, where you have an agreed definition of good enough, accuracy, fairness, performance, and risk thresholds. You also have reference scenarios and examples, which are examples of not only the acceptable ones, but the unacceptable AI outputs as well. You also have known edge cases and high risk scenarios, and very well documented assumptions, risks, and any open questions that we will be validating during the build or the pilot period. What happens immediately after is that the build sprint begins, where engineering teams starts to implement the prioritized scope. Design supports the implementation throughout the process, where they are constantly handing over design assets, providing any behavior clarifications, any support for edge cases and real world constraints. And then we have demos and reviews to validate the behavior that we've built against the decisions that we made during the 5 day sprint. And also to confirm if the success criteria and guardrails are actually holding in practice. Day 5 ensures the AI experience is not only well designed, but executable, accountable, and ready for the real world deployment. And that is the real shift. Once implementation begins with clear priorities, defined guardrails, and instrumentation in place, AI stops being an idea in a slide deck. It becomes a system with intent, accountability, and measurable progress. And that's the difference between experimenting with AI and engineering it with confidence. And that's why this sequence matters, where you have sense defining the opportunity, shape defining the experience, and steer helping you define how we trust, measure, and evolve it. Thank you for joining us on this walkthrough. We're excited to see you how you apply this framework for the AI experiences you're building.